So welcome back students. In this video we'll discuss about the batteries and its types. So what is a battery? So as we all know, battery is a source of energy which converts chemical energy into electrical energy. Okay. So batteries represent a silent form of energy producing chemical devices which generate electricity on demand. So what are the components in a battery system? So a battery contains anode, cathode, electrolyte, a separator and a container. So you can see the cell construction of a battery. So here we can see anode, cathode, electrolyte. They are having a separator and a container. Okay. So in anode, oxidation reaction takes place. That is, it releases electrons and it will be negatively charged. And in cathode, reduction reaction takes place. That is, it consumes electrons and it will be positively charged. And you can see electrolyte. So what is an electrolyte? So it is an ion conducting medium which conducts ions between the electrons. So you can see this is a working principle of a battery or a cell. So here the electrons flow from one electron to another electron and thereby electricity is produced. To understand this in detail, we will see a video on electrochemical cell.
Electrochemical cells. Conduction of electric current in solution of salt, acids, etc. The device through which chemical energy changes to electrical energy is called electrochemical cell or voltaic cell or galvanic cell. The change of chemical energy to electrical energy causes lowering of free energy, which appears as electrical energy and measured in terms of EMF, electromotive force. In an electrochemical cell, chemical reaction takes place in two compartments, each of which is called a half cell and contains a suitable electrolyte and electrodes. The two compartments are connected through an inverted U-shaped tube containing a mixture of agar-agar jelly and an electrolyte like KCN, potassium cyanide, or KNO3, potassium nitrate, or NH4NO3, ammonium nitrate, is called salt bridge. Salt bridge connects the two half cells. It prevents transference of the solution from cell to another, helps to maintain electrical neutrality in the half cells, prevents accumulation of changes, prevents liquid junction potential. The salt bridge can be replaced by a porous partition like paper strip, clay porous pot, unglazed porcelain or asbestos fiber. The electrochemical cells can be reversible or irreversible.
Okay, now coming to the classification of batteries. Batteries are classified into two. First is primary battery and secondary battery. So we'll see what's the difference between a primary battery and a secondary battery. Okay, so primary battery means they can be used only one time. That is, they are non-rechargeable batteries. Cell reactions are irreversible in these batteries. So the popular example is Lagrange cell or the zinc carbon cell. So it is mainly used in torchlight, portable radios, toys, novelettes, etc. At the same time, we are also having a high capacity battery, that is NG-MnO2 cells, which is used in the military communication, voting machines, etc. The reserve battery. So one of the cell components usually here used will be electrolyte, and it is kept isolated from the rest and is added at the time of need. So popular example is MgCuCl2 cells and MgAgCl cells. It is mainly used for the meteorological and defense field. And we are also having thermally activated batteries which is used in the missiles. Example is LiFeS2 cells. Now what is a secondary battery? So secondary battery means they are rechargeable batteries. That is, here the cell reactions are reversible. So popular examples are lead acid batteries, cadmium battery, nickel ion battery, nickel metal hydride battery, lithium battery and lithium ion battery. So we will see it in detail what are these batteries. Okay, so we'll start with the primary battery.
Primary cells are not rechargeable and are discarded after they run down when all the chemicals are used up. In other words, no more chemical potential energy available, or the chemicals in the battery can react to produce electrical energy. Here I go the illustration of what happens to the primary cell. The anode loses electrons to the cathode and both connected by a wire. Here the cell generating electrical current, but when the battery is run out of reactants and almost they all turn it into products, the cell stops working and it can't be recharged again. So here is an example on primary cell, which is dry cell. Dry cell battery is a voltage producing battery containing the electrolyte chemical in the form of a thick paste. It produces voltages of about 1.5 volts. In this diagram, which represents the parts of a dry cell battery, the zinc casing provides enclosing to the electrolyte and the cathode as a whole. Ammonium chloride is the electrolyte used in this type of battery. Just ahead of the electrolyte lies a manganese dioxide, separated from the electrolyte by a separator. At the center of the cell battery lies a carbon rod, which is the cathode, and zinc casing is considered as the anode. So let's understand how it works. Every portion of the battery device has chemical reactions occurring within. While a reduction reaction occurs at the carbon electrode, oxidation proceeds at the zinc casing, which is the anode. The chemical reactions that define the entire energy process are as follows. At the anode, zinc loses 2 electrons and is converted into zinc 2+ ion. The ammonium ion from ammonium chloride reacts with the 2 electrons to produce ammonia and hydrogen gas. The manganese dioxide near the cathode reacts with hydrogen gas liberated to form manganese 3 oxide and water. Combining equation 1 and 2, we get the following equation. And combining all the above equations, we get. Due to these reactions, chemical energy gets converted into electrical energy. This energy then flows from the battery to the connected device.
Anode is made of zinc powder and cathode is made of manganese dioxide. Anode acts as positive terminal of the battery. Cathode acts as negative terminal of the battery. Alkaline battery gets its name from the potassium hydroxide electrolyte, which is an alkaline substance. Brass pin in the middle of the cell collects the current. Separator is a fibrous fabric that separates anode and cathode touching from each other. When battery is connected to external load, electrochemical reaction takes place. When electrochemical reaction takes place, anode experiences an oxidation reaction. At the same time, cathode experiences reduction reaction. It means anode releases electrons and cathode attracts electrons. So negatively charged ions, that is electrons, move to cathode. Thus movement of electrons causes current in the external circuit. The brass pin collects the current. As long as the battery is in use, zinc gets oxidized and manganese dioxide is reduced. Interaction between zinc and electrolyte gradually slows down and manganese dioxide gets depleted. This effect causes a drop in the battery working voltage.
Manganese oxide battery is a primary battery, means the reaction is irreversible and it's a non-rechargeable battery. Let us discuss the construction and working of lithium manganese oxide battery. In lithium manganese oxide battery, anode used is lithium metal itself, cathode as manganese oxide treated at 350 degrees Celsius. The electrolyte used is lithium halide, any lithium halide dissolved in organic solvent. The diagrammatic representation of lithium metal hydride battery is as follows. This is the lithium metal and this is the cathode, that is manganese oxide, and this is the separator. Usually used separator is polypropylene. Its entire thing is enclosed in an ebonite case. The reactions that occur in lithium manganese oxide battery are as follows. At anode, metal lithium undergoes oxidation to give lithium plus ion, that is lithium ion, and an electron. And at cathode, manganese oxide undergoes reduction reaction to give lithium manganese oxide. That is, here the oxidation state of manganese is +4. This accepts one electron to give Mn +3. So here lithium, the overall reaction is lithium plus MnO2 gives lithium manganese oxide. So this minor change here is at cathode MnO2, the oxidation state of Mn is +4. After reduction, it becomes +3. The applications of lithium manganese oxide battery are, they are used in memory backup devices, used in watches, calculators, automatic cameras, and many electronic devices.
And the last one, heavy duty zinc chloride batteries. So here the anode used is zinc and cathode used is manganese dioxide. Electrolyte will be zinc chloride aqueous electrolyte. So features of this battery is they have a better resistance to leakage, better at high current drain, and better performance at low temperature. Thank you.